Hey everyone, just wanted to take a minute to talk about isosceles triangles and equilateral triangles. Hopefully, a lot of this information will be things that you probably already know or would have kind of guessed. Um, but just for formality, let's make sure we know what everything is. So, as a quick little recap, an isosceles triangle, you may recall, that's just a triangle where there are two or more congruent sides. Okay. So technically speaking, it could have all three. It's just we typically call an isosceles triangle with all three um, congruent, equilateral, congruent sides. I should finish writing that. Okay, so we have two or more congruent sides. You probably would have known that. Typically, when you see them, you'll know that these two sides are congruent. This one's not. It could be. And when it is congruent, it is an equilateral triangle. So that is where we have all three sides congruent. All right. Again, that's probably something you already knew, but let's just make sure that we are on the same page. So, what is our goal? We're going to prove and talk about some statements relating to isosceles triangles and about equilateral triangles. All right. We're going to use those to solve some problems as well. So, what do we have for vocab? Just to make sure that we're on the same page when we're talking about isosceles triangles, there is a few pieces of information we need to know. So we have the legs. These are the congruent sides, right? These are going to be the congruent sides of the triangle, obviously, of triangle. Right. So these two would be the legs. The ones where they're both the same. The vertex angle. That is the angle formed by the two legs. Okay, so this one up here, this is the vertex angle. See how it's where the two legs come together? That's what makes it the vertex angle. All right, and then finally the base angle, there's two of them. There will be two base angles, and the base angle is obviously above the base. So the leg, we have the two legs, and then the third side is the base. All right, and the two angles that are formed by the intersection of each leg with the base are the base angles. The angles formed by the intersection of leg and base. All right. So they are formed by the intersection of the leg and the base. We'd have these two. As we're going to find out later, they're also congruent. You, again, probably would have guessed that, but that's just something to keep in mind. Okay. So here are two of the big things that we really care about when we're solving problems. And this comes from, there's two theorems here. There's the isosceles triangle theorem, and then there's its converse, right? Conversely, its converse. So if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So basically, what is this saying? This one right here is telling us if I have a triangle, and I know that this side and this side are congruent, I can then tell you, doing no extra work, that these two angles are congruent. Okay? So if I know the sides are congruent, basically, if I know it's an isosceles triangle, I know the base angles are going to be congruent. All right? So what is this saying? This is just saying that base angles are congruent. Okay. Conversely, all right, so this is the converse. So we're just going to switch it. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. All right? So basically, what are we saying here? Now we're saying we have the angles. And if I have the angles and I know that they're congruent, I know that the sides are congruent. Okay? So essentially, what we've done is we've switched the ordering. right? So if I have that the base of these two angles are congruent, I know it's isosceles. If I know it's isosceles, I know the angles are congruent. All right. Now, why is that true? Well, the reason it's true essentially comes down to if you break it into two triangles, you can use side, side, side to prove that these two triangles are congruent, and as such, you would have the by CPCTC, you'd be able to get that the angles are congruent. You could use a similar process that's slightly different for the converse, but it just comes down to a matter of which method you use. But very similar. All right, so let's do some practice with the sides. So we have a triangle. Okay. I'm just going to draw it real quick. NOP. I know that O and P are O and N are congruent. Okay. We know that NO is 13. We know that PN is 19. Find OP. All right, well, what do we know? Well, we have that the angles are congruent. Therefore, we know that these two sides must be congruent. So if this one's 19, OP is 19. Simple as that. In an isosceles triangle, ABC, angle B is the vertex. All right, so this is going to be the vertex right here. So that means if this is the vertex, these two are going to be the base angles, right? Because if this one's the vertex, the other two must be the base angles, which means that these two sides are congruent. AB is 6x plus 3. BC is 8x minus 1. And AC is 10x minus 10. And then we're going to find the value of x. Well, what can we do? We know that these two are congruent. That means these two are equal to each other. 6x plus 3 equals 8x minus 1. So 4 equals 2x, right? I just subtracted the 6x, added the 1. So x will equal 2. All right, now it wants each side, so I'm going to plug it in. So AB, if I plug it in here, that would be 12 plus 3, which is 15. Well, we already know this one should be 15, and you can confirm that by plugging in the 2, right? 16 minus 1, 15. So BC is 15. And then we have AC, right? 10 times 2, which is 20, minus 10 is 10. And there you have it. So simple enough. All right, now let's do a little bit of practice with the angles. Okay. So we have triangle, and if they don't give you the triangle, just do a quick sketch, right? That'll help you. RST, we know that TR and ST are congruent. Okay, those two are congruent. We know that this one's 142. All right, and we need to find S. Well, what do we know about these two angles? They're the base angles, so they are congruent. I don't know what they are, but they are the same. So if this one's X, this one's X, right? They're the same. So I have that 142 plus X, and we know that all the angles of a triangle equal 180 when they're added together. All right, so we have 142 plus 2x equals 180. So that would be 2x equals 38. So my x, which is my measure of both of these, by the way, is 19. So the measure of angle S equals 19. All right, simple enough. Now we have another one. We have triangle UVW. And notice it doesn't matter what I'm, how I'm writing these. I could write any order. I just have to follow what it tells me to do. UV, VU. Okay, so these ones are congruent. W is 31. And my goal is to find U, so I'm going to call that X. Well, what do we know? Since these two sides are congruent, these two angles are congruent. So if that one's 31, this one's 31, right? So 31 plus 31 plus X equals 180. So 62 plus x equals 180. X is going to be 118. All right, so because x is 118, the measure of angle U equals 118. Oops. Okay, 118. All right, so that should be simple enough. Let's look at one more just to make sure that we're on the same page. So find the measures of the angles. This one has some variables, right? So these two sides are congruent. These two angles are congruent. So that one's 10x plus 10. Okay, that's x plus 10. This is x plus 10. All right. So we have x plus 10 plus x plus 10 plus 3x equals 180. So I'd get 5x plus 20 equals 180. 5x equals 160. Right? We divide 160 by 5. You'll get 32. And now we just need to plug in. All right? So when we plug that in, the measure of angle B is going to be 32 plus 10, which is 42. The measure of angle G is also going to be x plus 10, which is 42. And then U, the measure of angle U, will be 3 times 32, which is 96. All right. And there you have that. Simple enough. All right. Now, as we had said, equilateral triangles, what do we know about them? All their sides are congruent. So what can we say? If an equilateral triangle, if a triangle is equilateral, it is equiangular. So what do we know by that? So if we have the three sides are congruent, we know the three angles are congruent. Similarly, if we know the three angles are congruent, the three sides must be congruent. All right, it's the same thing from before, except now we're just adding in an extra side. So what does that mean? What are all sides? We don't know what all the sides are. The sides are just the same. However, if all three angles are the same, that means that they would be x plus x plus x equals 180, right? So that would be 3x equals 180. So x would equal 60. So if we know it's an equilateral triangle, we know that all three angles are 60 degrees. Okay? So that'll help us. All right. So let's look at how to solve these problems. So these ones are dealing with the sides. So we know that these sides are all congruent. That means x equals 10. We also know that y plus 3 equals 10. So y equals 7. All right. All three sides are congruent. So these two sides are congruent. So this is 2x plus 29 has to be equal to 41, right? So 2x, when we subtract the 29, 12. So x would be 6, right? So x in there is 6. Now the angle, this one in here, this is an angle. So we have 5y plus 2 equals 60. 5y equals 58. So y would equal 58 over 5. Not a pleasant number, but it works. All right, and there you have it. So if you have any questions on equilateral isosceles triangles, please feel free to reach out. I am happy to help. Have a great day.